everyone, and welcome to Sally and Bytes. Today, I am here to teach Chapter 6, Strings in Python, Part 2 for the Class 11 students of Computer Science. In this video, we are going to discuss about string operators, concatenating strings, replicating strings, membership operators, comparison operators, string slicing, strings are immutable, and practical implementation. So let's dive in and get started. We have already learnt about strings in the previous video. Strings are arrays of bytes representing Unicode characters. However, Python does not have a character data type. A single character is simply a string with the length of 1. Square brackets can be used to access the elements of the string. Now, in this video, we are going to discuss about the string operators. In Python, string operators allow you to perform various operations on strings. While Python doesn't have any special string operators specifically dedicated to strings, it provides a set of operators and methods that can be used to manipulate and concatenate strings. Here are some commonly used string operators and methods in Python. Concatenation, replication, membership operators, comparison operators, and slicing. Let's see one by one in detail. Now, let's discuss about concatenating strings. We know that we can add two integer numbers. But, we can also add two strings in Python. Concatenation refers to creating a new string by adding two strings. To concatenate means to join. The plus operator joins or concatenates strings written on both sides of the operator and creates a new string. Now, look at example 1. This code will concatenate the strings str1 and str2 using the plus operator and store the result in the result variable. When you run this code, it will output hello world because the plus operator concatenates the two strings together, resulting in a new string that combines the contents of str1 and str2. In this output, both are joined together without any space. Now look at example 2. In this Python code, str1 equals hello. This line assigns the string hello to the variable str1. str2 equals world. This line assigns the string world to the variable str2. Result equals str1 plus space character plus str2. This line concatenates the strings stored in str1 and str2, with a space character in between them. The plus operator is used for string concatenation. The resulting string hello world is assigned to the variable result. Print result. This line outputs the value of result, which is hello world, to the console. So, when you run this code, the output will be hello world with a space between both strings. Look at example 3. You cannot add a string and an integer objects. To use plus operator, data types should be the same. Now, look at this Python code. str1 equals 6. This line assigns the integer value 6 to the variable str1. str2 equals computer. This line assigns the string computer to the variable str2. Result equals str1 plus str2. This line attempts to concatenate str1 and str2. However, since str1 is an integer and str2 is a string, Python will raise a type error because concatenation between different data types is not allowed. Print result. Since the error occurs in the previous line, this line will not be executed. You can use concatenation operator plus with numbers and strings separately for performing addition and concatenation operation, respectively. Now, look at example 4. Number 2 plus number 4 equals 6. This is addition. String 2 plus string 4 equals string 24. This is concatenation. Remember, the expression string 2 plus number 4 shall generate an type error, as we cannot add a string and an integer. Let's learn about string concatenation using join method. The join method is a useful way to concatenate multiple strings together. It takes an iterable, such as a list or tuple, of strings and concatenates them using a specified separator. Here's an example of using the join method for string concatenation. Now, look at the code. In this code, we have a list strings containing 3 strings, hello, world, and exclamation point. Remember, lists are enclosed in square brackets. In the second line, we specify the separator as a space character. In the third line, the join method is then called on the separator, using strings as the iterable. The output will be, hello space world space exclamatory point. The join method concatenates the strings in strings using the specified separator, resulting in a single string where each element is separated by the specified separator. Note that the join method is called on the separator and not on the strings themselves. This is a common source of confusion. In Python, you can replicate a string by using the multiplication operator, asterisk. This allows you to create a new string by repeating the original string a certain number of times. Here's an example of using string replication. Now, look at the Python code. In this code, original underscore string is the string hello. By multiplying it by the number 3, original underscore string times 3, we create a new string that repeats the original string 3 times. The output will be, hello hello hello. The asterisk operator repeats the string original underscore string 3 times, resulting in a new string where the original string is replicated consecutively. You can adjust the number after the asterisk operator to control the number of repetitions. For example, original underscore string asterisk 5 would repeat the string 5 times. Now, look at example 2. In this Python code, the original underscore string is set to the string 5. By multiplying it by 3, original underscore string times 3, we create a new string that repeats the original string 3 times. The asterisk operator repeats the string 5, 3 times, resulting in a new string where the original string is replicated consecutively. In this case, the string 5 is repeated 3 times, resulting in the string 555. Always check if the strings are enclosed in quotation marks. Multiplying the strings 6 and 9 together directly using the asterisk operator will raise a type error in Python. The asterisk operator in this context is used for replicating a string by a numeric value, integer, not for multiplying strings together. You can check the output displayed on the console as type error, can't multiply sequence by non-int of type str. In Python, membership operators are used to check if a particular character exists in the given string or not. The two membership operators in Python are in operator and not in operator. Let's see in detail one by one. Let's discuss about the in operator. The in operator returns true if a character or substring exists in the given string and otherwise it returns false. The syntax is substring in string. To use membership operator in strings, it is required that both the operands used should be of string type. Let's see some examples. Look at example 1. The in operator is used to test whether a value exists within a sequence. In this case, the sequence is the string hello, and the value being tested is the character h. In this case, since the character h is present in hello, the expression evaluates to true. Therefore, when you run the code, it will output true. Look at example 2. The Python code print, y in hello, checks whether the character y is present in the string hello and then prints the result. In this case, the sequence is the string hello, and the value being tested is the character y. In this case, the character y is not present in hello, so the expression evaluates to false. When you run the code, it will output false. Look at example 3, Python code print, he in hello, checks whether the substring he is present in the string hello and then prints the result. In this case, the substring he is not present in hello, so the expression evaluates to false. When you run the code, it will output false. Here Python is being case sensitive, checking uppercase and lowercase also. Look at example 4. This Python code checks whether the string variable str1 is present as a substring within the string variable str2. In this case, str1 is butter and str2 is bread and butter. The in operator is used to test whether str1 exists within str2. In this case, since butter is indeed a substring of bread and butter, the expression evaluates to true. Therefore, when you run the code, it will output true. Look at example 5. This Python code checks whether the string variable str1 is present as a substring within the string variable str2. In this case, str1 is jam and str2 is bread and butter. The in operator is used to test whether str1 exists within str2. In this case, since jam is not a substring of bread and butter, the expression evaluates to false. Therefore, when you run the code, it will output false. You can check the outputs on the console. Let's discuss about the not in operator. The not in operator returns true if a character or substring does not exist in the given string, and otherwise it returns false. The syntax is substring not in string. To use membership operator in strings, it is required that both the operands used should be of string type. Let's see some examples. Look at example 1. The expression y not in hello evaluates to true because the character y is indeed not present in the string hello. The print function is then used to display the resulting value, which is true, on the console or output screen. Look at example 2. In this code, the expression h not in hello evaluates to false because the character h is present in the string hello. Therefore, false is displayed when the code is executed with the print function. Look at example 3. In this code, the expression bread not in bread and butter evaluates to false because the substring bread is indeed present in the string bread and butter. Therefore, false is displayed when the code is executed with the print function. Look at example 4. In this code, the expression jam not in bread and butter evaluates to true because the substring jam is not present in the string bread and butter. Therefore, true is displayed when the code is executed with the print function. You can check the outputs displayed on the console. Let's discuss about the comparison operators. Python provides several comparison operators to compare values and determine their relationship. Some commonly used comparison operators in Python are equal to. Checks if the values on both sides are equal. Not equal to. Checks if the values on both sides are not equal. Greater than. Checks if the value on the left side is greater than the value on the right side. Less than. Checks if the value on the left side is less than the value on the right side. Greater than or equal to. Checks if the value on the left side is greater than or equal to the value on the right side. Less than or equal to. Checks if the value on the left side is less than or equal to the value on the right side. Python compares strings using ASCII, or Unicode value of the characters. Unicode values are also called ordinal values. Python starts by comparing the first element from each sequence, character by character comparison. If they are equal, it goes on to the next element, and so on, until it finds elements that differ. Subsequent elements are not considered, even if they are big. Let's see an example. Example 1. In this code, the strings being compared are Mary and Mac. When comparing strings lexicographically, each character's ASCII, or Unicode value is compared from left to right until a difference is found. The first two characters from str1 and str2, M and M, are compared. As they are equal, the second two characters, A and A, are compared. Since they are also equal, the third characters, R and C, are compared. Because R has greater ASCII, or Unicode value than C, str1 is greater than str2. Thus the output displays false on the console. In these Python examples, Python compares using values, called ordinal values. The most common characters and their ordinal values are given in this tabular column. Now, look at the tabular column. Character 0 has the ordinal value 48, character 1 has the ordinal value 49 up to character 9 has the ordinal value 57. Next line, character uppercase A has the ordinal value 65, character uppercase B has the ordinal value 66 up to character Z has the ordinal value 90. Next line, character lowercase a has the ordinal value 97, character lowercase b has the ordinal value 98 up to character lowercase z has the ordinal value 122. Using these ASCII values, that is, ordinal values, let's try these examples. Now, look at example 1. The Python code print Tim equal to Ty compares two strings, Tim and Ty, to check if they are equal. The double equal to operator is used to compare the two strings for equality. The first two characters T and T are compared. As they are equal, the second two characters I and I are compared. Since they are also equal, the third two characters M and E are compared. Because the ASCII values of M and E are not equal, the output displayed is false. You can check the ASCII values of M and E on the right side in the tabular column. Now, look at example 2. The Python code print free not equal to freedom compares two strings, free and freedom, to check if they are not equal. The entire expression free not equal to freedom evaluates to true because the strings are not equal. Now, look at example 3. The Python code we have to check if arrow is greater than Aaron. The first two characters, A and A, are compared. As they are equal, the second two characters R and R are compared. Since they are also equal, the third two characters R and O are compared. Because the ASCII values of R is greater than ASCII values of O, the output displayed is true. You can check the ASCII values of R and O on the right side in the tabular column. Now, look at example 4. The Python code checks if right is greater than left. The first two characters R and L are compared. Because the ASCII values of R is greater than ASCII values of L, the output displayed is true. The character R in right comes after the character L in left. So, output displayed is true. You can check the ASCII values of R and L on the right side in the tabular column. Now, look at example 5. The Python code checks teeth is less than T. The first two characters T and T are compared. As they are equal, the second two characters E and E are compared. As they are also equal, the third two characters E and E are compared. They are also equal. Hence, it checks for the fourth two characters but string T doesn't have any more characters to check. Hence, the output is false as the result, indicating that the string teeth is not less than the string T. Now, look at example 6. The Python code checks yellow less than equal to fellow. The first two characters Y and F is compared. As the ASCII values of Y is greater than F, the output displayed is false, as the result, indicating that the string yellow is not less than or equal to the string fellow. You can check the ASCII values of Y and F on the right side in the tabular column. Now, look at example 7. The Python code checks ABC is greater than single space character. Here, you have to remember that any non-empty string comes after an empty string. In this case, a space character is the empty string. So, when you run this code, it will output true as the result, indicating that the string ABC is greater than the string single space character. Based on their ASCII values, you can check the ASCII values of A and space character on the right side in the tabular column. In Python, String slicing refers to the technique of extracting a portion or a substring from a string by specifying the starting and ending indices. So what is a slice of a string? A slice of a string is a substring. This extracted substring is termed as slice. Chunk of characters can be extracted from a string using slice operator with two indices in square brackets separated by colon. The basic syntax for string slicing in Python is string name open square brackets, start colon, stop colon, step, close square brackets. Here stop is excluded. Here's what each part of the slicing syntax means. String underscore name. The original string from which you want to extract a substring. Next is start. The index representing the start position of the substring, inclusive. Next is stop. The index representing the end position of the substring, exclusive. Next is step. It is optional. The step or increment value for selecting characters. It determines how many characters to skip while slicing. If step value is positive, move in forward direction. If step value is negative, move in backward direction. Let's see an example. Look at example 1. A string variable named string is defined with the value hello, world. The code substring 1 equals string of 7 : extracts a substring from the original string hello, world. Now look at the picture. The index value of the string hello world is marked, starting from 0 and ending till the end of the string, that is index value 12 for exclamatory point. Now let's see how string of 7 : works. Now, look at the bottom for the syntax of string slicing. Remember the syntax of string slicing. String underscore name of start : stop : step. Here, start value is 7. Stop value is not given, so we have to take the default value till end of the string. Here end of the string is index value 12 and holds the character exclamatory point. Step value is also not given, so we have to take the default value as 1. As the step value is positive 1, we have to move in forward direction, that is forward indexing. So finally, we get the output as WORLD exclamatory point, starting from 7th position, till the end of the string. Let's see another example. Look at example 2. In this Python code, a string variable named string is defined with the value hello, world. The next line of code creates a new variable named substring2 and assigns it a value obtained by slicing the string variable. Slicing is a way to extract a portion of a string based on its indices. In this case, the indices used are 0: 4, which means the substring will start from index 0 and go up to, but not including, index 4. Look at the syntax of string slicing at the bottom. Syntax is string underscore name of start : stop : step. Here, in string of 0: 4, the start value is 0, the stop value is 4. We have to stop at 4. So 4 is not included. So, stop value is 3. Step value is not given, but the default value is 1. As the step value is positive 1, we have to move in forward direction, that is forward indexing. So finally, we get the output as HELL, starting from 0 and ending in 3rd position. You can check the output on the console. Let's see an example. Look at example 3. In this Python code, a string variable named string is defined with the value hello, world. The next line of code creates a new variable named substring3 and assigns it a value obtained by slicing the string variable. The slicing expression used here is string of : 2. Now look at the syntax of string slicing at the bottom. The syntax is string underscore name of start : stop : step. In string of : 2, the start value is the default value 0. The stop value is not given. So default value till end of the string. Here, step value equals 2. As the step value is positive, we jump 2 steps forward each time, starting from 0 until the end of the string, which means every second character of the original string will be included in the resulting substring. Therefore, the output will be HLO space character, OL exclamatory point. You can check the output on the console. Note that when you omit the start index, it defaults to 0, and when you omit the end index, it considers all characters till the end of the string. Let's see another example. Look at example 4. In this Python code, a string variable named string is defined with the value hello, world. The next line of code creates a new variable named reversed_string and assigns it a value obtained by slicing the string variable. The slicing expression used here is ::(-1). When using the ::(-1) notation in a slicing expression, it indicates a step value of -1, which means the string will be reversed. The slicing starts from the end of the string and goes backwards, including every character. Now look at the syntax of string slicing at the bottom. The syntax is string_name of start: stop: step. In string of ::(-1), the start value is not given, so default value is -1, as step value is negative. So it starts from the end of the string. That is, it starts from exclamatory point. Stop value is not given. This means that the slicing operation will continue until the beginning of the string. So until index -13, which holds the character h. Step value is -1. As step value is negative, jump 1 step in backward direction. Therefore, the output will be exclamatory point DLROW space character, OLLEH. This is because the slicing operation reverses the original string and includes all the characters in reverse order. Let's see another example. Look at example 5. Write a Python program to input name and print the pattern as given below using string slicing. If name Python, output should be P, PY, PYT, PYTH, PYTHO, PYTHON pattern. Now, look at the screen to see 4 boxes here. Now come on, look at box number 1. This is the Python code. In line 1, it prompts the user to enter a name and store it in the variable name using the input function. In line 2, it uses a for loop to iterate over a range from 0 to the length of the name, inclusive, using the loop variable I. Inside the loop, extract a substring from the name using the slicing operation name of 0:i, which includes characters from index 0 up to, but not including, index I. In line 3, it prints the extracted substring using the print function. The loop iterates, incrementing I by 1 in each iteration, resulting in a growing substring length. The loop terminates when I reaches the length of the name, ensuring the final iteration prints the entire name as the last substring. Let's see in a detailed manner so that you can understand well. Now look at box number 2. The syntax of range function is range of start, stop, step. In this Python code, range of 0, len of name plus 1, the start value is 0. Stop value is len of name plus 1, that is, len of Python plus 1 is equal to 6 plus 1 is equal to 7. 7 is not included. So, stop value is 6. Step value equals 1. Now look at box number 3. The syntax of string slicing is string_name of start: stop: step. In this Python code, name of 0:i, the start value is 0, stop value is I, value is 7. 7 not included. So, 6. Step value is the default value 1. Now look at box number 4. Iteration of the for loop for the name Python. User input, Python iteration 1, I is 0. Slicing operation. Name of 0:i implies name of 0:0, it is an empty slice. Output is an empty line. Iteration 2. I is 1. Slicing operation. Name of 0, I implies name of 0, 1. This includes the first character. So, output is P. Iteration 3. I is 2. Slicing operation. Name of 0, I implies name of 0, 2. This includes the first two characters. Output is PY. Iteration 4. I is 3. Slicing operation. Name of 0, I implies name of 0, 3. This includes the first three characters. Output is PYT. Iteration 5. I is 4. Slicing operation. Name of 0, I implies name of 0, 4. This includes the first four characters. Output is PYTH. Iteration 6. I is 5. Slicing operation. Name of 0, I implies name 0, 5. Includes the first five characters. Output is PYTHO. Iteration 7. I is 6. Slicing operation. Name of 0, I implies name of 0, 6. This includes the entire name. Output is PYTHON. The loop iterates a total of 7 times, each time increasing the value of I by 1. With each iteration, a substring of the name is extracted using string slicing and printed on a separate line. The substring grows in length from the first character to the entire name, resulting in the desired pattern. Let's see how it is practically implemented. Now look at the output. User enters the name as Python. In the first iteration, an empty line is implemented. In the second iteration, it includes the first character, P. In the third iteration, it includes the first two characters, PY. In the fourth iteration, it includes the first three characters, PYT. In the fifth iteration, it includes the first four characters, PYTH. In the sixth iteration, it includes the first five characters, PYTHO. In the seventh iteration, it includes the entire name, PYTHON. In Python, strings are immutable, which means that once a string is created, it cannot be changed or modified. Immutable objects cannot be altered after they are created. When you perform operations on a string, such as concatenation or slicing, it doesn't modify the original string but instead creates a new string with the desired changes or subset of characters. Now, let's look at a simple example showing strings are immutable, that is, once created, it cannot be changed or modified. Now look at the Python code. Line 1 assigns the string Jim to the variable name _1. The variable name _1 now holds the value Jim. Name _1 of 0 equals T. This line attempts to modify the first character of name _1 by assigning the value T to name _1 of 0. However, this will raise a type error because strings in Python are immutable, which means you cannot directly modify individual characters in a string. In the line, print of name _1, since the previous line raised a type error, this line will not be executed. If we run this code with the attempted modification name _1 of 0 equals T, we would encounter a type error indicating that strings are immutable and cannot be modified in this manner. Thanks for watching. Watch the upcoming videos. Chapter 6, Strings in Python Part 3. String methods and built-in functions. And practical implementation. You can check the link in the description box below.